In this third segment of the video, we're going to take a look at making another mathematical model, this one for a situation where a frog is hopping along. Here's the data that we've collected, already plotted, and so we'll recall that what we want to do is to write out our equation for a line, a general equation for a line that we've learned in math class. And then we want to fill in particular or replace particular values. So the y value here is the position of the frog. Maybe the frog is hopping along one of our rulers. So let's use P for position. And then this m is the slope. All right, well, we're going to have to go ahead and find that slope. So let's draw a line up from here to where it meets the axis and then over. Alright, that happens to land on a data point, but there's no need for it to be on a data point. And let's come up here to the line here because we need a rise. We need to find the slope. We need to do rise over run. Alright, so the rise is from position 1 to position 3. Alright, so from 1 up to 3, and the run is from time 0 time 1. So that's going to be a rise of 2 over a run of 1, which is of course 2, and that's going to be in meters per second. Meters, rise, run, seconds. Alright, so the slope is going to be 2. Now this x will be the value along the x-axis, which is time in seconds. Let's use a t for time. And then this is going to be our y-intercept, which has a value of 1. Alright, so there is our mathematical model. Now before we go ahead and try to use this mathematical model, let's interpret the meaning of some of these things. The meaning of the slope here is the number of meters per second. That's another word for speed. And so the slope in this mathematical model represents the speed. How steep this line is, the slope of that line represents the speed. This represents the initial starting position, the start position. Where was the frog when we started the stopwatch? So maybe he was hopping along a series of our meter sticks and he was already at the end of one of them. So he was at position of 1 meter. Alright, well, let's go ahead and try to use this to say, alright, well, at what position will the frog be at after 10 seconds? So where will the frog be at 10 seconds? Alright, so our model says the position of the frog will be equal to 2 times the time plus 1. Let's put our numbers in. 2 times 10 seconds plus 1, and if you do the math out, you'll get 21 meters. So the frog will be at a position of 21 meters, assuming he doesn't get too tired and stop hopping. All right, let's try another example. Let's recall our mathematical model was P equals 2t plus 1. And now let's ask ourselves another question, which is how long for the frog to get to 47 meters. Alright, so position 47 meters, we want to know how long it will take the frog to get there. Alright, so we simply solve this for time. Subtracting 1 from both sides gives us 46 equals 2t. Divide by 2 gives us t equals 23 seconds. And that's our answer to how much time it will take the frog to get to that position. In the next segment, we'll look at